another presentation on Thursday where I'll talk more generally about the sort of ethos that I was referencing in the intro about what it's going to take for different sorts of service provider to look at the sort of huge acceleration of interesting new technologies and actually apply it to sort of commercial services. And we heard from Anne something which is still in the lab, and I thought that the idea to sort of blend 3D and AR with IMS is interesting, because I've been a long-term critic of IMS, and that's probably the first time I've actually heard of a use case which isn't me too. So I quite like that. And then AI here in a particular part of network management. But I think, and I'll talk about this a bit later on, one of the things that I see is services is new technologies applying across the communications industry in multiple different touch points, and I'll cover that in a second. So, don't know what the feedback there was, but we'll go with that. So I'm going to talk a little bit about blockchain. I'm going to say up front that I am not a developer myself. I'm an industry analyst and consultant, and I cover a whole range of different areas. So you'll hear me talking about voice and video. I've spoken at this event before about WebRTC. I talk about what 5G and NFV is going to look like on the network side of things. But recently, I've started doing more work looking at the intersection points between the telecoms industry and various other things which are cool and new. And some of them are not even new, but still in development. I was at a quantum computing event recently, and that has some very interesting implications and applications and possible risks for the communications industry. And one of the things that clearly is given a lot of people a lot of thought in the last couple of years has been partly cryptocurrencies like Bitcoin, but also the underlying platform that's beneath that called blockchain. And I'll just give a little bit of an intro into some of the thinking that I'm doing at the moment about where blockchain might intersect with the telecoms industry. Could I just show a quick show of hands? Who here is familiar with what a blockchain is or does? Good, right. So I can skip over some of the slides here because you probably know more than I do. But the genesis of what I'm doing here was I contributed a chapter to a book, not my book. There's a futurist, a guy called Rohit Talwar, a year or so ago, on the future of business. And I covered an area on the future of the phone call, looking at WebRTC and video and contextual communications and so on. And the thing which really struck me was all the other chapters in this book. And a large proportion of them had some relevance to the communications industry. We've just heard about AI, for example. Big data is no surprise. Contextual communications and computing. Blockchain and shared ledgers are coming out from the financial industry to other sectors. And then a bunch of others. Some of it, I'll be honest, is not relevant to the telecoms industry. I don't think the artificial meat industry, interesting though it is going to be appearing here anytime soon. But blockchain is definitely one of the hottest topics in terms of VC funding and arguably hype. And so what I'm really interested in is where all of these new technologies intersect either with communications and collaboration or with future network technologies. Because there's both revenue and cost-saving opportunities which align with everything from 5G innovation through to what we've been hearing before around whether it's AR and VR. Internet of Things is going to be covered in its own track, but also stuff like WebRTC. And these intersections come in unexpected forms and ways. And I just want to drill into one area now. So blockchain, for those of you not familiar, and this is a very, very primitive description. This was originally a slide build, but I've now done it as a PDF, unfortunately. The first square block there, imagine you have a number of transactions. Now, this has started from a Bitcoin point of view, but you collect a number of transactions, and like in any other sphere of industry, you want to store them in some sort of database. Now, historically, there would have been a centralized database, typically either run by a company or a specific intermediary, say a bank or a credit card company. The idea behind blockchain is to distribute a database, or sometimes it's called a shared ledger. And so it is potentially owned by the collective of people both writing and reading data related to those transactions. And there's a variety, and I'll come on to it in a second, there's a variety of ways of constructing these type of distributed ledger systems. But the basic principle is this word consensus. You have a large number of computers that together combine a number of transactions, encrypt them, and turn them into a block. In this case, using a hash function. And the interesting thing here is that this is based in part on the shape and format of the previous block of transactions. And by using a large distributed number of computers, computer nodes to actually perform the calculation, you can create a provable, immutable chain of transactions that are linked together all the way back to the very first one. And so each group of transactions, and here it depends on what type of blockchain we're talking about, is linked to an unchangeable archive. And so by using the heavyweight computing power involved in what's called proof of work to assert that the data is what it says, you can prevent, certainly in a financial context, problems that might occur in a financial system like double spending of money. We're fine in a database if it's, say, content management. Let's just say most content people can copy. If I create a photo on my PC, clearly there's some questions around digital rights management in a media industry context, but you don't mind data being duplicated. You do mind digital money being duplicated because you only have one particular Bitcoin or fraction thereof. And that was why this mechanism was invented initially for cryptocurrencies, but is now turning into be a new form of database and data storage mechanism for a lot of other applications. And why this is so interesting, you must think, well, it's just another database. Yes and no. Because it is a database which is not centralized, it means you can do away with centralized intermediaries. Now, that's not a big deal if you're one company storing your own data on your own system. But if you are, as we increasingly are, in a networked economy where there are multiple parties involved in buying something, selling something, confirming something, acting as a trading platform of one form or another, then that ability to have a distributed function without paying rent, the inefficiency of a centralized authority or a third party that's charging fees to act as an intermediary is a big deal. And this stems from a financial system, where, for example, if I paid someone in this room, whether it's via PayPal or I actually try to do a money transfer, given I've got a UK bank to a US bank, there are probably 10 intermediate steps. And if there was a way of transferring money instantaneously and simply and provably and securely without the various financial intermediaries, that would be a good thing. That translates into other industries in a whole set of unexpected ways. And so you're starting to see this concept of a chain of trust and a non-changeable distributed database applying anything from verifying the provenance of a diamond and recording it in a ledger so that people can inspect it, through to, as I'll talk about in telecoms, it could be something like a number portability database. Or it could be the state of a virtualized network function in an NFV deployment, and to prove the data, the integrity of the software and that it hasn't changed. There are, and I don't have time to talk through it, and I'd say there are probably people who know this more than me, there are variations on a theme here. Of do you store the whole amount of data you want on the blockchain itself, or do you essentially do what's called a hash of that data and store the hash rather than the data? Do you take this whole large lump of, say, billing records or an image, or do you just take something which represents and itself proves the existence of that image and its contents? There are some problems and downsides here. leaving aside even, the first thing that people, when you talk about blockchain, the first stumbling block is, oh, that's that thing to do with Bitcoin, I'm not sure we want to get involved in that. The if you like, guilt by association with some of Bitcoin's less savoury use cases tends to put people on the defensive straight away. Luckily, this is starting to move away as blockchains expand beyond the original use case of cryptocurrency, in particular Bitcoin, into these other areas. And particularly they're being worked on by very large and established IT and consulting companies. If you look up on blockchain, you'll come across Accenture, Deloitte, IBM, and a bunch of startups as well, and particular consortia run by, say, the financial industry. So there's the R3 consortium, which is a group of large and well-known investment banks. Other issues here are around power consumption used in the cryptographic processes and the proof of consensus, and also how any of this fits in with what people have done historically. And that's a huge issue in the telecoms industry, particularly if you start talking about billing systems and OSS and network management. One of the things you will find if you delve into blockchain at all and you watch anything, there's some really interesting videos on YouTube and a lot of articles, is there is a fairly large sci-fi element to this, where people say, because we can do this, we can change everything that involves trust anywhere. We can create new forms of government, we can redefine corporations, which corporation is just a way of having mutual trust between employers, shareholders and employees. We can reinvent the entire world. This is the biggest thing since the internet. Now, it's possible that you could write that type of vision, but that is somewhere over there at the moment. And so you have an awful lot of authors writing books talking about the sci-fi version without actually talking about how we get to it and what the use cases, particularly the commercial ones, are between here and now. Worth pointing out, there are different sorts of blockchain. And in particular, there's a difference between the blockchain and a blockchain. The blockchain is usually referring to the Bitcoin, the original underlying database and distributed ledger underneath the usual cryptocurrency that we're familiar with. There's then a number of other public blockchains. Ripple is one, and Ethereum is more of a platform, blockchain platform on which can be built various applications, and there is a cryptocurrency called Ether built on top of that. There are what are called consortium blockchains, like the one I mentioned for banking at the moment. Today, there is nothing like this in the telecoms industry, and I think one of the things that I would like to see over the next 12 months is various people who are either telcos or vendors, or perhaps people from academia related to telecoms, start to think about whether it's a consortium or a standardized telecom-specific blockchain might look like. And the last one is what are called private or permissioned blockchains, where you are people taking the guts of the technology and applying it to, say, the insurance industry or property, or I saw something recently on trade finance, where there isn't this need for the entire world to get involved in this sort of consensus-building approach. In terms of the provability, but it can be done with a smaller set of parties involved, and this starts to look a lot more like an industry value chain, whether it's in telecoms or energy or elsewhere, where you can define the type of blockchain, you can decide how much trust or lack thereof there is between the parties. And there's a variety of sort of hybrids, what are called side chains. There's this term DAO you will come across, which stands for Distributed Autonomous Organization, which is essentially a company which owns itself and doesn't necessarily have traditional shareholders, which is all very much in the interesting but not immediately relevant bucket, I would say. You've arrived when there's Dilbert cartoon. This is certainly one of those things where there's an awful lot of people who have a blockchain-shaped hammer and everything looks like a nail. And I think that there's a big risk that we sort of try to go after use cases and applications that frankly, there's better ways of doing. And this is not just about blockchain, but one of the things that annoys me about the telecoms industry at the moment is there is not a recognition that for any problem, there are 5, 10 or 100 ways to solve it, with different costs and different sets of issues and different timelines. So, for example, if you want to create a vehicle which doesn't have a driver in it, you could make it completely autonomous, or you could have a remote driver. Some people are talking about having remote or VR and AR-driven vehicles for building sites, for example. And so the net result is perhaps it's cheaper, perhaps you, as the passenger, don't have to have someone sitting in front of you. Whatever the outcome is, it is a driverless vehicle, even if whether it's autonomous or the driver is somewhere else, is perhaps immaterial. So I think that it's important here, whether we're talking about blockchain, IMS, even Wi-Fi, is not to get too precious. And I think that the industry has been guilty of being precious about an awful lot of things over the years. So this is a slide which is a work in progress, and that will explain the et ceteras, which is partly because it's work in progress and partly because this is on video, and I'm hoping to do some more work on this over coming months. The way that I think about blockchain and telecom use cases is around a grid format. And what I've got here is, on the horizontals, there are different things you can do with blockchain. The one we're familiar with is payments. Bitcoin and potentially micropayment transactions, and using the blockchain as a basis for essentially storing ownership rights to money. And that has applications in the communications industry as well. But there's a lot of other things you can do horizontally with blockchain. And one of the ones which seems to be getting most traction at the moment is what's called data integrity. And this is a broad class of uses where you can use the distributed ledger to prove that data you have now hasn't been changed. And there's a lot of reasons why you might want to do that. So using a telecom specific example, an operator recently at an event I went to was talking about information requests from government for data records. And the question then is, if we get a request to hand over Dean's call data records, who have I called, how can the telco prove to law enforcement that the data they hand over is actually what came out of the back of the network over the last couple of months? What's the anti-tamper mechanism for that? So that was a use case, whereas if you can demonstrate that the call detail records coming out of a network are hashed together and in a way that they are provably non-changed over time, that adds a huge amount of value to the compliance department. Now, it's not a new service, but if you are concerned about compliance, that may well be a good example. IoT is another area where data integrity is important, where you pretty much do want to know that the firmware in your self-driving car hasn't been changed maliciously overnight by someone. And there's a whole range of IoT things here where you quite like to know that software is what it's supposed to be from, there's an authenticity thing here. If you like, there's security has a number of components. There's confidentiality, use encryption. There's proof of who you are, various techniques for authentication. But there's also proof that the data is what it's supposed to be. It hasn't been changed. And I think that that has a lot of applicability in, it could be network management around network function virtualization. Is that VNF the right one? There's some interesting things around preventing fraud in wholesale and roaming. Is that call record we're reconciling at the end of the month between two service providers actually genuine? So there's that horizontal there. And then there's what are called smart contracts. Smart contracts are ways of creating computer-based trading agreements between two or more parties which are conditional upon external variables and which actually execute in different ways automatically. So an example might be, again using an IoT example, that you will do company A will pay company B for delivery of refrigerated goods as long as it can be proved that the temperature in the container didn't go above freezing at any point in the journey. And the question is whether you can actually represent that sort of agreement as essentially a computer-based contract and settle it where you have data from, in this case, it could be a temperature sensor, which is proven and immutable. So you perhaps record the temperature sensor data provably, which potentially on a ship that goes across the ocean, which is out of connection, but it is storing that data in a way that is later trustworthy. And then, if all the conditions are met, the contract pays out. And there's a lot of other ways you could imagine that in the telecoms industry in terms of how you design future contracts for, it could be billing plans, but equally it could be to do with settlement and wholesale. There's enterprise applications. We're really at the very early days of this. The idea of a smart contract is not new. It was dreamed up, I think it was about 22 years ago, but we're only now starting to get to the technology where you have the ability to have self-administering conditional contracts. And then, looking at the verticals here, there's separate domains within the communications industry, whether there is, the network itself is a whole range of sub-elements, but managing the network, you have roaming and wholesale relationships, you have billing and OSS for consumers, you have real-time communications, think examples like the lawful intercept or perhaps number portability databases I was mentioning before, a whole range of stuff around IoT, which has the advantage of not having any legacy to change. And then there's cloud, there's enterprise communications, TV and entertainment, and so on. So TV and entertainment, it could be more around content management and asset protection, and asserting who owns what in terms of user-generated content, for example. And you could imagine having the assertion of identity coupled to a smart contract for user-generated content in an entertainment part of a service provider. I'm still working, if you like, on overlaying a heat map on this. But the areas which at the moment seem to be the ones which seem to be getting the most attention are probably around the top two horizontals, the data integrity and micropayments, and to a degree identity, although it's a little bit more opaque at the moment. And I would say IoT is the sort of, probably the hottest area. But there's a lot of other interest in, I was talking to a few use cases in the NFV and SDN world of how do you manage third-party VNFs, virtualized network functions, is a good case study. There's a couple of people I've talked to looking into that. The anti-fraud, particularly around wholesale and interconnect payments, and proving that calls terminated were actually genuine, and the record-keeping example I gave before. But I've come across other ideas, and at the moment it's still just at the idea phase around, say, spectrum management and trading. Could you use blockchain to store spectrum ownership rights as a use case, and perhaps to sort of manage the transactions between multiple parties? There's a set of areas where blockchain tends to be applicable, and that tends to be in multi-party transactions. And also a critical one to think about is the time frames. One of the issues that blockchain certainly has at the moment is scalability. The public Bitcoin blockchain, now this is not the only one, but the one that's best known, has a capability of a grand total of 7 transactions per second. Count them. Yeah, 7. And to do that, it has such a large network of computing nodes to actually prove that the consensus has been generated. That, well, one statistic I heard suggested that it has roughly the same electricity consumption as the island of Cyprus. Whether that's true or not, I'm not sure, but even to an order of magnitude, that clearly is not a sustainable number. So a question about that. Potentially, yes. There's a lot of discussion about block size and various other sort of parameters and metrics on that. But when you get into the other sorts of blockchain with the permissioned and private blockchains, for example, then scalability is a lot more feasible. So I saw a press release today of some new blockchain-based application platform that can handle, I think it was 87,000 transactions per second. So there are ways in which some of the scalability is being dealt with. But there's also a latency and a timing issue. And roughly what I was thinking here is, I think that when we look at the telecoms industry specifically, the early use cases for blockchain are going to be things which don't change that fast. And so things like number portability, monthly reconciliation between carriers for traffic, those are sort of on the time frame of yearly or monthly or maybe daily if you've got sort of keeper lives. For an IoT, for a sensor that is off net some part of the time. And I think that the sort of second and millisecond sets of data that we're used to in the industry, I don't see those being intersected with blockchain anytime soon. Now, there are ways in which they could be, but I think that in terms of just the dynamics of the industry, we're going to be on the sort of right-hand side of the logarithmic scale for now. So, I'm just going to wrap up. I've got a couple of slides because we're running out of time. There are some early movements in the telecoms industry around blockchain that I'm seeing. A couple of the more public ones is Orange has an investment in a company called Chain. Verizon has invested in an IoT company called Filament that has a combination of hardware and software to deal with remote IoT implementations, which may well be partly off net, and where there's actually sort of a quite clever way of not just storing the data, but using a mesh network approach to communicating it on an ad hoc basis. There's a company in the Emirates that is looking into using blockchain in its healthcare vertical services that it's working on together with the government. Ericsson has been talking heavily about this data integrity horizontal, especially with a company called GuardTime, which it partners with. IBM, I've heard recently talking about blockchain at an event I went to in Mountain View, and that they were saying that they've been working on micropayment use case, among others. And then I've talked to a few other companies that are active in this area, and there seems to be quite a lot going on behind the scenes. However, I have to say that the telecoms industry is slower than I might expect at the moment. And whilst there are some sort of talks, and I bump into whether it's Verizon or BT or NTT at a few events, I think that compared with certainly finance, but also some other industries like perhaps even utility and property, and government, there's quite a long way to go. There's also quite a lot of scepticism, partly because of the scalability issue, but also because there's a lack of standards at the moment. So I did a quick search on a random selection of industry bodies, and with the exception of GSMA, I'll come on to that in a second, 3GPP, FCC and OPNFV just typed in blockchain into the search engine. Now, I could have done it more thoroughly with distributed ledger and a few other things, but I got a big round zero on those other three. GSMA, and that's partly because it reports on news and stores various conference content from third parties in its website, has a bit more, and I know that they're in early stages of looking at blockchain use cases. But when I tried to interview them, I got the impression that it's still too early to talk publicly. So at the moment, blockchain is a little bit orthogonal to the traditional telecoms sort of industry establishment. And I'd quite like to see a bit more thought on what a telecom blockchain working group, any of these, might look like. But the thing here is there's so many different use cases that it's not obvious to me whether you would cherry pick one or two, or whether there is an argument for a more general sort of telecom blockchain consortium or something like that. So sorry? I will look at that one. IETF, yeah? Okay. Good, right, okay. I'll add that to the list. So, to sum up, my view is that the sort of telecoms sort of industry is going to adopt blockchain only slowly, and particularly, when I hear that people saying, "Oh, it's going to be it's going to replace the billing system, it's going to replace the SIM card, all the rest of it," I don't think so. I think that the sort of existing security mechanisms, the existing sort of billing and operation systems are unlikely to undergo some radical transformation in the next 2 to 3 years. Beyond that, maybe. I think that there's areas where there are intermediaries involved, which people are going to start looking at using distributed ledgers as a way of reducing costs and friction, although there does not quite as much as there is in, say, the finance industry by a long way. I also think that we're going to see blockchain as perhaps an enhancement of various of these processes. So compliance being a case in point, where it's not replacing an existing system, but enhancing one. I think that the new areas, the sort of greenfield services that the telecoms industry is looking at, especially IoT, is where we'll probably see quite a lot of movement first. And I think the data integrity area strikes me as one with quite a bit of potential. I think smart contracts sound fascinating, but I think we're at very early days. There's going to be quite a lot of intersection points where telecoms itself is moving into different vertical markets. You see a lot of, say, service providers looking at everything from smart metering in energy to facilitating e-government, healthcare. There's usually discussion here on things like telemedicine. And you could imagine things like health records being run as a cloud service. Now, it doesn't have to be. There the question is that just a telco acting as an IT company rather than a communications provider? Maybe. I think there's some interesting stuff around sort of the guts of the network, whether that's NFV, SIM management, spectrum management, but I don't think that's going to happen soon, although it wouldn't surprise me to see some pilots, some working groups, as you've mentioned, and perhaps a couple of interesting startups emerge. But I think that the consortia and standards initiatives, and I'll take on board what you're saying about IETF. I spoke to the Hyperledger Consortium, which is one of the large open source groups, and they don't have a telecoms working group the way they do have one set up recently for healthcare. But I'm curious to see if that evolves. So overall, I am cautiously positive. I think there's already an awful lot of hype around blockchain. I don't buy into some of the sort of libertarian sci-fi visions that we're going to completely reinvent global society and the nature of the corporation. And I think we'll have a fair amount of time to warn us before it does. But I think there's quite a lot of other stuff where there is some interesting potential, and it's not just another database. Thank you.